Hi, welcome to my YouTube video assignment. In this assignment, I'll be talking about dissociations in the neurosubstrates of language and social functioning in autism spectrum disorder. To start off with some background information, autism spectrum disorder, or ASD, includes impairments in social communication skills and pragmatic language. Pragmatic language is the ability to use and comprehend social language interaction with others, which is central to ASD. Some common measurements of ASD include the Children's Communication Checklist, the Adults Communication Checklist Sub-Report, and Communication Checklist Adult. The breakdown of those checklists includes different aspects of language communication ability using three subscales. The first one is language structure, which is speech, grammar, and syntax. Next, pragmatic skills includes the ability to use and comprehend social language in interaction with others, and social engagement, which is one's degree of participation in a community or society. Different versions of the CCC consistently show that both pragmatic skills and especially social engagement scores were lower in children with ASD compared to the same age TD children. Moreover, social deficits are considered the most salient symptom of ASD. There has been abundant research on anatomical differences in the social brains of adults with ASD compared to TD controls, showing thinner cortex and decreased gray matter. Because of the heterogeneity of deficits seen in ASD, it is difficult to differentiate which of these regions are associated with either language or social-related deficits in ASD. As a motivation for this study, the limiting linking brain structure and behavior in ASD has rarely utilized self-reported measures. Up to date, there has been no investigation of neurosubstrates of multiple aspects of language as assessed in the CCSR. Therefore, in this study, they want to first investigate the profile of self-rated language and social communication deficits among adults with ASD as compared to the TD controls. Second, they want to examine the language communication skills profile and its association with gray matter structure in adolescents and adults with ASD in comparison to the TD group. For the methodology of the study, they have included 64 TD individuals ranging from age 16 to 36-year-olds, and they have also included 52 individuals diagnosed with ASD ranging from age 15 to 31-year-olds. First, to measure language social communication skills, they have utilized the communication checklist sub-report, including the three subscales. Next, in order to capture the structure image of every participant, they have utilized a high-resolution T1 weighted structural image. And lastly, they have utilized the free surface image analysis method to view surfaces and generate cortical thickness at each surface vertex. When examining ratings on the CCSR, the ASD group self-rated lower language social communication skills than the TD group on all three subscales. Also, there was a significant group difference of the two of the three CCSR subscales. As you can see on the image, pragmatic language was associated with increased cortical activation in left rostral middle frontal cortex. Next, social engagement skills was correlated with increased activation in left medial orbifrontal cortex. These interactions were driven by lower self-ratings of language social skills on the CCSR being associated with thinner cortex in the ASD group. Surprisingly, TD group showed the inverse relationship where lower self-ratings was associated with increased cortical thickness. Only the pragmatic language subscale association with cortical thickness was discrepant between ASD and TD groups. This was driven by significant positive correlation between pragmatic language and cortical thickness in the left inferior frontal gyrus and rostral middle frontal gyrus in the ASD group, which is a region implicated in phonology and semantic processing. As an overall summary of this study, there was a strong behavioral difference in language and social abilities between ASD group and TD group, where in the ASD group, greater pragmatic language deficit was correlated with thinner left inferior frontal cortex, while greater social deficit was correlated with thinner left ventromedial prefrontal cortex. Meanwhile, in the TD group, inverse relationships were poor scores on language and social communication, where they were correlated with thicker cortex. These results provide evidence that thinner cortex in adolescents and adults with ASD is associated with worse self-reported functioning in two key components of ASD phenotype, which is pragmatic language and social communication. For the implication of the research paper, pragmatic language may have separate neural substrates from more basic structural language abilities in ASD. From past cross-section studies and longitudinal studies, they have shown that increased cortical thinning in ASD during adolescent and young middle adulthood, and this increase in cortical thinning is associated with behavioral difficulties. The current study extends these findings to another important characteristic of ASD phenotype, which is pragmatic language abilities. Thinner left inferior frontal cortex was associated with lower self-ratings of pragmatic language, while thinner left medial prefrontal cortex was associated with lower self-ratings of social functioning. This is the study that I've used for this reference. Thank you so much for watching my video.